place that made nerd cool.
The most popular password in the United States is password 123.
Those are some of my previous passwords.
Who on earth would actually fall for that?
Sensitive information has been sort of given to the wrong hands.
Hey, everybody. Welcome to this edition of the Security Repo podcast. I am Dwayne McDaniel, developer advocate here at GitGuardian, and I am very pleased to introduce Nathaniel McCallum, CTO at Profian, who will be giving us a heads up today on a few different topics. One, the main reason you probably tuned in was the title of this episode, WebAssembly and Building More Secure Apps. But we'll also be talking a little bit about the history of Profian and some other security topics around that. So with that, would you care to introduce yourself? Give us a little bit about your background, Nathaniel?
Sure. Thanks, Dwayne. It's really a pleasure for me to be here. I come from a very long background in the open source space. I've been doing open source really for 20 plus years. 10 years of that was at Red Hat, where I was had many different roles over the 10 years. Last one being the virtualization security architect. And today I'm CTO of Profian. Profian is a startup in the confidential computing and WebAssembly space. We see really the exciting advent of two new technologies that we're trying to combine in a way that's interesting and compelling. Those are confidential computing and WebAssembly. So again, thank you for having me on the show. It's a great pleasure to be here.
It's an interesting company name, Profian. Where does that even come from? What does that mean?
Yeah, it's actually a Middle English word. It's the ancestor of the modern word proven. When you've completed your mathematical proof, you might say that it is proven. So Profian comes from the Middle English Profian, which is the ancestor of that word proven. So the important thing is that we're trying to everything that we do, we want it to be mathematically proven. So we want to always be transparent about all the processes that we have. We're a security company, and so transparency is really important to us. And we really want to emphasize the ability of being able to do provable compute, so that you can always know that what you are running is what you would hope to be running. So.
Even though it's a Middle English word, it sounds French in origin. And, well, we're a French company at GitGuardian, who sponsors this podcast. So very interesting.
Yeah, you can thank the Normans for that.
Yes, definitely. There's a lot to dig into here. But for the audience that tuned in, let's start with WebAssembly.
Sure.
Because that's why I think some people are watching this right now. So for those people who are brand new to the subject, let's give it a 10,000 foot view. How would you describe WebAssembly to someone that's just getting started with web development?
Yeah, absolutely. So WebAssembly is a technology that emerged in the browser. And to be clear, we are not a browser company. We are taking WebAssembly out of the browser. But WebAssembly emerged as a browser technology. And the fundamental problem was that although JavaScript has served us very well over the years, there were specific corner cases where we really needed better performance in the browser. And so WebAssembly was essentially launched. It was first launched, I believe, in 2015. And it emerged from really two side projects. One was ASM.js from Mozilla, and the other was Google Native Client, also called Salt, because it was spelled NACL. So any of the chemists that are listening will know why it's called Salt. And so the Native Client and ASM.js were the precursors to WebAssembly. And WebAssembly then emerged in the browser as a standard across all browsers. And it basically allows you, it's a compilation target. So you can take a compiled language like Rust, C, Go, Java, etc., and you can compile to a WebAssembly artifact, bytecode, WebAssembly bytecode, and then you can deploy it in the browser. There's a lot of interesting things happening with WebAssembly outside of the browser as well, which is really where we are headed as a company.
What's the adoption footprint look like for this? Do you have any stats on that? Like how many developers, what percentage of the web is moving with WebAssembly or moving to WebAssembly?
In terms of the website, I don't have stats off the top of my head. Like I said, we're focused on the outside of the browser case. But WebAssembly does something really interesting for us as an industry, which is that it gives us an industry standard bytecode without a huge API surface that we've traditionally had in the past with things like JVM, right, where we had a bytecode, but it was tied to a particular vendor, and it also had this massive standard library that everybody had to implement, and so it saw limited traction. You saw companies like Google, of course, going and creating the .NET platform as a response to that. WebAssembly for the first time is really giving us just the bytecode, right? Just the bytecode runtime, and what does that actually look like, and how can we get really good performance and security out of it? And so that's very usable and redeployable as a tool to lots of different problem sets. So in the browser, it's seen tremendous adoption. I know that all browsers today ship with WebAssembly out of the box. Anybody that's doing anything high performant in the browser world today is using WebAssembly for that.
Awesome. It does sound like it solves the same promise the JVM all those years ago promised us, that you could write once, run anywhere.
Yeah.
But that assumed everyone was going to have a JVM. That assumed everyone was going to set up a Tomcat server, which I don't know if you've ever done that. I haven't done it in years, but not trivial.
Yeah.
Not trivial. Yeah. And I love the fact that it is agnostic and just across all the browsers. That is, again, one of the big issues with the JVM in general is, like, which JVM are you talking about? What version of Java are you talking about? I assume WebAssembly is going to hit those same issues eventually.
Yeah. So WebAssembly is interesting because it's independent in another regard. Not only is it cross-platform, but it's also cross-language, right? When the JVM first came out, Java was really the only language in town that worked for it. And so it was a bytecode that was designed for a very, very specific language, where WebAssembly is not. It is designed for all languages, which is why you have tons of languages having very good support for WebAssembly these days. That includes not only your standard traditional languages like C and C++. You have newer compiled languages like Rust and Go. Of course, a lot of people are using these languages these days. But even dynamic languages, Python has official builds of WebAssembly for WebAssembly these days. Ruby has official builds. Even TVM is one of the Java implementations, and you can use that to generate WebAssembly as well. So it's very, very not only cross browser but also cross language.
Well, we are on the Security Repo podcast, so I have to ask, what security issues is WebAssembly addressing? Is it better than the JVM approach? I mean, JVM has a lot of exploits like Log4j we saw not too long ago, or Log4Shell, and all the exploits of that. But what issues is WebAssembly trying to solve with security?
Sure. The initial attempt of WebAssembly was not to create a better security platform, but we do think it is a better security platform, so we'll talk about why. The initial goal was really just to focus on performance. However, there's significant effort being put into what's called the WebAssembly component model. If you Google that, you'll find plenty of resources. And the component model is basically a way to create interoperability across all of the languages that can compile to WebAssembly. So this would allow you, if you're writing one module in Rust and you're writing another module in Python and another module in Java, that they could all be able to talk to each other and have efficient usage of the APIs. And there's some very specific benefits that come out of this. One is this concept of shared nothing linking. The idea of shared nothing linking, of course, is that they don't share a memory space. And so a compromise in one module does not lead to compromise for another. This is really great for multi-party compute use cases. So if you have multiple different parties who are contributing code or data to a computation, they can be able to do this computation with a high degree of confidence that even if there's a risk in somebody else's, that it doesn't necessarily lead to a disclosure of their own data if it's carefully constructed. So that's a very big benefit.
All technology carries some security risk with it. There's some security vulnerabilities pop up no matter what we try to do to be a more secure platform, a more secure world. What, if any, security issues are we seeing emerge around WebAssembly?
Yeah, we're not seeing a lot of new security issues that are being caused by WebAssembly. I would say, for example, in the browser space, the primary concern is that when Spectre and Meltdown happened, of course, in the past, there were certain mitigations that were put in place into JavaScript in order to prevent exploitation of those CPU vulnerabilities. And there was some concern, for example, that WebAssembly would also be able to exploit those. But notice that that's a vulnerability not in WebAssembly, but in the actual CPU. It's not like we don't have more modern CPUs these days. You're welcome to upgrade to the latest. There's also patches and such for the existing CPUs. So WebAssembly is not really causing any new security issues in that regard.
All right on. Well, that's encouraging to hear. We will see what the future holds, though. We can't hold our breath too much for everything to be perfectly secure forever. Black hats, the malicious actors of the world, are always going to try to find an exploit here or there. So we'll be carefully watching the CVEs and the MITREs of the world to see what emerges. But if someone wanted to get started with this stuff, if they wanted to go down a path of learning WebAssembly, what would be the path you'd send them on? Where would you send them for more information? How would you suggest they get started?
Yeah, I mean, really, Google is the is the place to go for information. Really, any search engine. There's tons of stuff out there. The NARCS project, which is what my company backs in the confidential computing space. We have tons of documentation on how to get started. A lot of the platforms that are out there that allow you to do things for WebAssembly outside the browser, they'll have tons of documentation. The big news, of course, outside of the browser is the WebAssembly System Interface, or WASI project, which is an attempt to actually create a standard system interface for WebAssembly outside of the browser.
Another topic that you mentioned earlier when you were doing your intro to Profian was around confidential computing, and that is an interesting term, especially here being on a security podcast. What does that even mean? What do you mean by confidential computing?
Yeah, that's a great question. So first of all, I'll say that I'm just here following the definition of the Confidential Computing Consortium. So there's actually a consortium that governs this definition. So I'm not just making this up out of nowhere. And if you want more information, please check out the Confidential Computing Consortium. So the Confidential Computing Consortium and the sub-industry that it represents really represents a new set of technologies that's come in the latest generation of chips. So these are broadly available, for example, in Intel Ice Lake Xeons, as well as AMD Milan in the EPYC line. And these allow you to run a computation, right? So you can run an application where the actual pages of that application, as they're kept in memory, are encrypted by the memory controller using a unique key. This provides several properties. First, it provides confidentiality and integrity of the data that's being run in the application. So if you have sensitive data like healthcare data or financial data or cryptographic keys or any of those kinds of things, right? All of those actually run encrypted in the memory. And even if you get a root level vulnerability, right, or ring 0, if you can actually get the highest privilege level on x86, for example, you still can't see into the data and you can't manipulate the data because it's actually enforced by the hardware. So that's a really big benefit, but it's actually not the biggest benefit. The next benefit that you get is the integrity of the code that's running. This is according to the definition. Now, NARCS also aims to provide integrity and confidentiality of the code, but what we mean here is that the code that's actually running runs in a way where you can't tamper with it. So you can't, at runtime, for example, attach a debugger to it and then change the instructions that actually are executing in that code. The third thing is that it provides, and we provide attestation. Attestation is a cryptographic proof from a hardware root of trust that the application is running in this kind of environment. And this is what allows you to run a process on one system and then to be able to connect to it on another system and know that it is running in a tamper-resistant environment. And we think attestation is really the big value point here. If you look, for example, IBM just released the cloud security study. A really great thing. Go Google it. It's fantastic. And they revealed, for example, that according to their study, the average data breach costs $9 million, and many companies have more than one in a single year. We have basically looked at that, and we've pointed out that if you look at all of the examples of these big vulnerabilities that have happened, the big data breaches that have happened, that should be more clear. They all have at their center a root cause, which is that people are accessing data in a way that they're successfully completing the authentication and authorization, but they're doing so, because they have keys, so they can spoof another user. What we're not seeing in the industry is we're not seeing a failure of authentication as designed. It is working as designed, but what we have a failure to do is a failure to scope disclosure of data to a particular operation. And this is precisely the tool that attestation brings to the playbook of everyone out there. So the example I like to give here is if you're a customer and you go to a bank and you say, "Hey, what is the balance of account 1234?" They're not just going to tell you that information. The first thing they're going to do is they're going to say, "Hey, who are you?" And they want to see some ID first, right? That's your authentication. And then they're going to look and see if you actually own that account and if you're privileged to have that information. And you can they see that you own the account, and therefore they are willing to give you information. They tell you what the balance of that account is. So you've just gone through an authorization and an authentication step. But what's interesting is that now that data is unscoped. They've given you that information, but what you can do with that information is absolutely unlimited. You could tell your friends, you could announce it, you could send it to a foreign power if you wanted to. So what you can actually do with that data is unscoped. And this is roughly the way that we treat all data systems on the internet today. And this is the thing that fundamentally needs to change if we're going to actually make a significant dent. By the way, the inflation in terms of cost for data breaches right now is, I think it was something like 22% over the last 2 years. So that's the cost of data breaches going up, right? And so this is a pretty fundamental problem. And the way we solve this with attestation is that rather than asking who gets access to the code and then letting them do whatever they want with that, we actually say, what are you going to do with that data? So and this is really important because in computing systems, there are no humans directly involved. Even if you're sitting at the computer typing, there's software in between you and that remote party, right? So what we really have is code talking to code. And when we disclose data, we need to ask not who owns that code or who is the host operating that code. What we really need to be asking is, what do you plan to do with that information? And we need to be able to scope how we can use, or when we disclose data, we want to be able to scope how it's used. And this is the main thing that's actually going to cause a big decrease in security cost in the industry.
There's a lot to unpack there. You said some scary numbers, but go back to something you said earlier, and that is authentication working as designed for getting into these systems. That's definitely something we've written about a number of times in our blog. Something that's alarming to us. The Toyota breach, the Uber breach, I'm sorry, is the one that comes to mind most recently, where it looks like they did set things up appropriately. It was a human being that got pushed to get to access, but once they were in, and at no point did the rest of the system say, "Hey, who are you?" and push back on any of the access keys they found in those PowerShell scripts internally. So that's very relevant for the constant conversation. That $9 million, I'd be curious. I'm going to dig into that after this call, actually, after this podcast, to dig into that, where that number, understand that number a little bit better. Because Because that's a very scary number.
It's a
If it's
very
per
small number.
incident.
So that comes from the IBM Cloud Security Study, if you in 2022. So that's the most recent numbers we have. If you Google that, you'll find the IBM study. It's a very comprehensive study. Now there's really some scary things in there. For example, companies who are highly exposed to the cloud, meaning they deploy a lot of things in the cloud, the average cost of their data breach is 68% higher than those who are hosting on-prem. Right. These are very, very big numbers, and there's real money that's being lost that could be redirected towards producing new value.
Well, I'm glad that you're working on this problem so we can eliminate those kind of fines and those kind of incident costs.
And it's not just fines and incident costs, right? You mentioned Uber. Well, the Uber had another data breach. I think it was 2019, but just in the month of October, the CISO that was over that data breach was actually found criminally liable. Right. So not only do we have significant cost increases to all of these data breaches, but we also have a shifting liability landscape where the people who are actually in charge of these systems are going to be found increasingly liable for the data breaches that occur under their operation.
Wow. Yeah, that another terrifying reason. But to go back and like boil it up a little bit higher, because again, you said a lot there when we started talking. It's obviously a subject you're passionate about around confidential computing. But it sounds kind of like that missing component because we've talked about securing data in flight a lot, and we've talked about securing data at rest a lot. And I think most people would think, all right, yeah, I've got the database encrypted and we're good there. And I got my pipelines, my actual, the pipes we're smart enough now to not, but read out of the temporary file and just read directly from the application if we're writing pipes. Or most developers are there. But yeah, it's interesting. That's not something I think of day to day. It's like the actual data in use and pulling it out from there. But wow, challenging. Yeah,
this is precisely what confidential computing is about, right? So we talk about encrypting data at rest and we talk about encrypting it in transit, but the missing gap is this data in use question, right? And this is why, for example, although encryption of data at rest is effectively a solved problem in the industry, what's not solved is the key management around it. For example, 17% of data disclosures happen just simply due to misconfiguration. Right. So the fact that you can just misconfigure these things because you've basically been given a pile of tools and it's your job to like cobble them together in some Rube Goldberg machine that is hopefully going to work when you're done and is going to be secure. You can't succeed in that kind of environment, right? You need a tool that basically integrates all of those things so that everything's encrypted while it's in use. And out of that comes the properties of being encrypted in transit and at rest. And this is precisely what the NARC's open source platform intends to do, is to shore all of this up. So let me tell you a little bit about what NARC's actually is and what it does. So the NARC's platform, by the way, you can find out more about NARC's at narcs.dev. That's enarx.dev. NARC's is an application deployment platform. We deploy WebAssembly applications into the cloud, and we do this using confidential computing so that your data is encrypted in use, in transit, and at rest. There's no configuration to make that secure, right? There's no double dash make it secure option. You can't get it wrong is the important thing we're driving at here. And so basically the entire time your application is running, it's encrypted in use, encrypted when it's writing to disk, and encrypted when it's writing to the network as well. Most importantly, we also handle all the attestation for you. So you can be able to basically generate a key pair. You can get a certificate for that, and that certificate guarantees that the application you're speaking to remotely is in fact running in what we call a keep, which is the trusted execution environment. And so that's essentially the platform that we're offering. Everything's open source. The NARC's platform is licensed under Apache 2.0. So come try it out. You can go to try.nrx.dev. And you can literally launch and run your own applications. Costs you nothing. You can be up and running in a few minutes and start experimenting. You don't need any special access to hardware through that. Everything will just work out of the box. So that's try.nrx. That's ENARX.dev.
Well, we will link that down below. Excellent. Well, just looking at time here, don't want to take up your whole day. But if there's any other articles, blog posts, anything else you would recommend how people can learn more about confidential computing or WebAssembly, where would you send them?
Yeah, absolutely. Check out the nrx.dev website. We've got a lot of information there about how you can get started with WebAssembly outside of the browser. A lot of the the same compiler toolchain information is shareable both inside and outside of the browser. But we have got a lot of information there. If you want to know more about the WebAssembly system interface, this is the set of syscalls essentially that allow you to interact with the system. You can Google for WASI, that's WASI. And that's a W3C effort. You can find more information there. As I mentioned before, information about the WebAssembly component model. You can Google those terms as well. You'll find the effort in the W3C there as well. We just the other thing is come talk with us at the NRX project. We'd love to hear your feedback. Chat.nrx.dev will get you to the right place. So really easy to get a hold of us, and we're happy to help you in any way we can.
Well, that's excellent. That's awesome. There's a community around it and somewhere where people can actually go talk to someone knowledgeable.
Yeah.
That's how we learn and grow, which is awesome. Well, Nathaniel, thank you so much for being on the Security Repo podcast. Again, I've been Dwayne. This has been Nathaniel. And if you have any questions, Nathaniel can be reached over there in the chat.nrx.dev community to follow up with you, he and his team. So thank you very much.
Great. Thanks, Dwayne.